Hello! This video will show you how to use push buttons with a breadboard, which will help beginner Raspberry Pi users to use buttons correctly and efficiently. This video is strictly about circuit work, and I will not include any related coding. If you are interested in adding code to buttons with Raspberry Pi, I have several other videos about that linked in this video's description. A basic button typically looks like this: a small square component with 4 connection pins. Whether you have a small or large variety, the function is the same. The role is to close a circuit, allowing electrical current to flow when pressed. While a typical button has 4 pins, we actually only use 2 of them for the electrical connection, with the other 2 serving as anchors, making a button more stable physically in the breadboard when pressed. Internally, opposing legs are connected in pairs permanently, and all 4 legs are connected through pressing the button. Due to this internal configuration, it matters where you place the button on the breadboard, how the button is rotated, and which pins are used to make the electrical connection. Most beginner resources recommend placing the button in the middle of the breadboard, over the breadboard's center line, so let me start with that configuration. I will build a basic circuit following the central button placement model, where I will use the button to light up an LED. Other than a button, here is what you need if you would like to build the circuit yourself: a breadboard, one standard LED of any color, one resistor 220 to 1000 ohms, and a power source. I will be using this inexpensive breadboard power module here. Such module energizes both pairs of the red and blue power rails of the breadboard. This module allows me to select the desired voltage by setting the jumpers appropriately. I will be using 3.3 volts in this example, but 5 volts will work too. If you have the same type of power module, make sure to install it correctly. Observe the plus and minus markings printed on the circuit board. The plus needs to be aligned with the red rail, and the minus need to be aligned with the blue rail of the breadboard. If the plus and minus do not align with the correct colors, you need to place the power module on the other end of the breadboard. Keep the power off until the circuit is completed. As I already mentioned, the typical beginner placement of the button is in the middle of the breadboard, across the breadboard center line. Most buttons fit only one way, and unless you have some very large variety, there's no risk of installing the button incorrectly using this placement method. Just make sure to push the button all the way in to get a proper connection. Here's a schematic diagram of the circuit I'm building. All components are connected in sequence. The power source provides electricity to the LED, with the button serving as a gateway. The purpose of the resistor is to limit the maximum current that flows through the circuit, protecting the LED from damage. The resistor is connected to red power rail, providing access to 3.3 volts. The other side of the resistor is connected to a button pin of your choice. In this breadboard location, the button is connected to 4 breadboard rows, but we pick one pair, located either diagonally from each other or on the same side of the button. We cannot use pins that are opposite. Opposite pins are actually connected to each other permanently inside the button, and doing so would render the button useless, with the circuit being always closed. In the diagonal connection method, the other side of the button, diagonal to the first connection, goes to the LED. We need to direct a longer LED leg, which is the plus side of the LED, towards the button, which brings the plus side of the power to the LED indirectly through the resistor. The shorter leg of the LED goes directly into the blue minus power rail. I am not using jumper wires here on purpose to make this circuit simpler. The circuit is ready. I can energize the power rails and use the button to light up the LED. If you want, you can swap the resistor and LED in this circuit. It will work just the same as long as you remember that the longer LED leg needs to be directed towards the plus side of the power. The LED will not light up otherwise. Let me swap the resistor and LED, and just for fun, this time I will use the other two diagonal pins of the button. The center of the breadboard placement of buttons with the diagonal connections works well and is recommended for beginners as it reduces opportunities for mistakes. It does, however, have some drawbacks. For example, it requires you to use power rails on opposite sides of the breadboard, blue rail on one side and red on the other side. This may not always be practical or desired. You can avoid this situation by utilizing button pins located on the same side of the button. The circuit and button will work the same as before, but now the circuit is more compact. I like this much better as breadboard space is limited and I do not like to waste it. Speaking of wasting space, this button as is occupies 4 connection rows, but only 2 are actually used for electrical connections. With the LED and resistor connected to the same side of the button, we can actually move the button towards them, placing the button entirely on one side of the breadboard. Doing that frees up 2 connection rows for other purposes and is a better button placement in my opinion. If you place your buttons off center like this, make sure to keep it oriented the same way as in the center position. Buttons cannot be rotated 90 degrees like this. Doing it would short the 4 pins of the button permanently through the breadboard connections and the button would not work. The off-center placement method may not work with larger buttons. Most large buttons such as this one have pins too wide apart to fit the breadboard. Again, you cannot rotate them 90 degrees to try to make them fit. The electrical connections require the button to be aligned correctly. I will show you a workaround for large buttons in a few moments, which makes placing large buttons off-center possible. Now that you have a general idea how buttons are used with a breadboard, let me show you how to use them with Raspberry Pi. The breadboard power module is not normally used with the Pi. Instead, we use GPIO ports as the base for the circuit. Using the Pi as an intermediary opens opportunities beyond simple on and off functionality. We can blink the LED or change brightness or control several LEDs at the same time with one button, which cannot be achieved with a simple circuit such as this one. If a Raspberry Pi project uses buttons to control LEDs, a button would not be used to provide power directly to the LEDs. Instead, a button is only providing a signal to the Pi, and we rely on software to control the LED. We do not physically connect the button to the LED. Let me show you this simple scenario here using a new breadboard with a Raspberry Pi cobbler connector. I connect the LED through a resistor to a GPIO pin of my choice, for example GPIO 26. The LED circuit is grounded by connecting the blue breadboard rail to a GND pin of the Pi. If I want to use a button to control this LED, I connect the button somewhere else, away from the LED. For example, on the other side of the breadboard to GPIO 21 using a jumper wire. Pay attention to the button placement, especially if your button is across the breadboard's center line. Make sure that the button does not share any connection strips with the LED, for example like this. That would be incorrect. Depending how you make that connection, you could damage your Raspberry Pi if you make a mistake here. The other side of the button is normally connected to a GND pin of the Pi, preferably using the blue breadboard rail. Some internet tutorials call for a resistor with buttons for Raspberry Pi, which is not correct. Buttons are connected directly to the Raspberry Pi. Do not forget to ground the button's grounding rail to a GND pin of the Pi. This is something I see forgotten all the time with my students. The circuit is ready, but it needs to be checked. Start with the GPIO pin that is assigned to the button. Follow the jumper wire to the button. Make sure the button is installed correctly. Then follow the button's other connection to the blue grounding rail, returning the circuit to a GND pin of the Pi. I could write a simple program now and control the LED with a button press. I will not go into this here as I have separate videos that discuss that in detail, and they are linked in this video's description. What I will go into instead is the button placement. As I already mentioned, I am not a fan of the central button placement method because it wastes breadboard space. If you use a small button, it can be moved off center as I did before, and this is what I would actually recommend. This way you free up 2 breadboard connection rows and eliminate the risk of cross-connecting the button with something else on the other side of the breadboard, for example this LED. I prefer using large buttons as they are much easier to press. Large buttons do not fit off-center, but there is a workaround which requires a modification to the button itself. Let's look at the bottom side of the button. Any protruding plastic bits such as these need to be removed first, as they would prevent us from installing the button fully in. Next, you need to bend up one of the button pins. It does not matter which one. Or if you do not mind making it permanent, remove the button pin altogether. The ultimate goal is to have a 3-pin button like this. We are almost done. I need to take out the original grounding jumper wire. It will not be used anymore. Also, the other jumper wire needs to be moved a bit to accommodate the new larger button. I connect the 1-pin side of the button directly into the blue grounding rail of the breadboard. Aligning the button so that the pin diagonal to it connects to the jumper wire leading to the GPIO. It is very important to check your circuit at this point. Start with the GPIO pin, whichever you chose for the button. Follow the jumper wire to the button. Continue diagonally through the button to the blue grounding rail, making sure there is only 1 pin in the grounding rail, going back to the GND pin of the Pi. Bending or removing the button's ground side pin was necessary, otherwise the button would be detected by the Pi as always pressed, when placed like that on the breadboard. Here the circuit is only closed when the button is pressed, connecting GPIO 21 to GND. The 3-pin connection method works with smaller buttons too. The only thing to note here is that small buttons will not reach the outer breadboard rail, so you are essentially limited to only one side of the breadboard. Placing them on the other side would pin you to the red 3.3 volt rail, which is not the default Raspberry Pi configuration with buttons. I like using buttons with 3 pins with Raspberry Pi, as it minimizes the amount of space that buttons take up on the breadboard and eliminates 1 jumper wire per button, which is always good. If you would like to see buttons in action with Raspberry Pi, check out the linked videos where I show programs in C and Python that do it. If you like this video, please give it thumbs up and subscribe. Thanks for watching.